So let's look into a couple of data manipulation steps. So what are the different data manipulation activities that we would take on a data frame? Let's explore the data frame using the visual tool. So we have the variable explorer and we have a data frame over here. If you take the expanded view, you'll have a glimpse into the entire data frame. But this is actually a difficult thing when you have several other columns. When we have 10 columns, it's a relatively easy thing to use the visual tool. So what if we want to actually access a particular column? That's a satisfaction level. How do we do that? In Pandas, it provides an intuitive way to access each column. So let's say we have the data frame. We can access each column with the with square braces and the column name in quotes. So we say satisfaction level. And if you press execute this command in the console, the entire column values are displayed in the console. Here we go. Now what if we want to slice out a couple of columns together and create a new data frame? We can do that saying, let's say we give a new name. We create a new data frame called df2. And let's say we plan to actually combine two different or three or four columns into a new data frame. So we have the existing data frame and we create a list of columns that you would like to actually create for the new data frame. Let's take the first one, satisfaction level. We can also have salary. We can also have sales. So these are three different columns. Do we need to add any more? For now, let's park over here. If you execute this command, you can see that we have created a new data frame with three columns. That is the entire length, 14999 rows and three columns. And these are the three columns which we have selected. Let's look into the visual tool. And yes, there we are. We have the three columns which we have selected with the appropriate values. So what next? What if we wanted to access a couple of rows and a couple of specified columns? Pandas provides an intuitive way to actually go ahead and slice your data. So let's say we have the data frame df. There's a function called iloc. It stands for index location and it takes into account two arguments. First, the length of rows, and second, the length of columns. So let's say we would want the first 10 rows. So you would say 0 to 10. Now this will actually give us rows from 0 to 9 and 9 stands for the 10th row. The next parameter would be the columns. So let's say we need the first 4 columns. So we would have 0 to 4. Now in this way, we take a small portion from the existing data frame. We take the first 10 rows and we take the first 4 columns. If we execute this and we create a new column called as df copy. This is a new data frame which we created. You can see that the data frame has been sliced into df copy. And there we are. We have 10 rows, 0 to 9, and the first 4 columns. Let's say we want to access a couple of random columns. So if we take into account the same data frame, and let's say we were interested to create a data set with the first, the fourth, and the last column, and then the first 500 rows. How do we do that? Now, the row axis and the column axis are pretty mature. So by default, let's say if you use defaults, so let's say we have colon, comma, colon. This means that it's actually taking into account the entire list of rows and the entire list of columns. We can actually say something like axis from 5th row onwards till the end and from the first one till the 4th one. So it actually has a more advanced way of accessing your data frame. So this indicates everything from the 5th row onwards, and this indicates everything up to the 4th column. Now, if you take into account and execute this command, you can see that yes, we have the first 4 columns, and then we have everything on the 5th column, 5th row. You can see a small reduction in the number of rows. Now coming back to the original example, we were interested in extracting the first 500 rows and specific columns of interest, the first one, the fourth one, and the last one. So what do? We would say we need all rows up to the first 500 rows, right? So we start with the default and end with 500. Next, coming to columns, since we need random columns, we can provide them as a list. So we need the first one, the fourth one, which is the third one in this scenario, and the last one, which should be the ninth one. If we execute this command, we have a new data frame with 3 columns. And these are the ones randomly selected based on our interest. The first one, the fourth one, and the last one. So this gives us an easy way to slice data. How do we create new data columns? How do we augment the existing columns? So let's say you want to actually create a new column. We could do that by providing a new column name. So we say column 1 for data frame is equal to 1. Now when we execute this command, Pandas looks into the data frame to find whether there's any column called as column 1. If it exists, it replaces the same column with a new value. If it doesn't, it creates a new column. So in this case, it will create a new column with the value 1. You can look into the same data frame and can see that there's a new column called column 1 created with the values 1 all over. So whenever you perform a column level operation, Pandas takes into account to replicate all of that across all rows. So you don't need to actually write a for loop and update this value across all rows like you would do it in a generic programming language. Pandas takes care of abstracting the entire scenario for you by just replicating the entire operation across rows. We could also create new columns using the existing columns. So let's look into the data frame once again. Taking an expanded view, let's think about a scenario where we want to create a new column which is a multiplication of number of projects and the satisfaction level, just to get a quantified impact of how much the satisfaction level of the employee impact the company. The more number of projects he's worked with, the higher impact. It may not make complete business sense, but the idea over here is just to showcase one additional data manipulation technique. So let's create a new column called as impact, which would be a multiplication of satisfaction level and number of project. So that could be done easily saying, we create a new column called df, give a name as impact, and we say df of satisfaction level multiplied by df of number project. There we go. If we execute this command, we can see that we've created a new column, which is now created by augmenting 2 different columns. So impact is created by multiplying satisfaction level and number of projects. Now in some cases, you might actually want to delete a column. So in this scenario, you've already created a column which you don't really plan to use, and that's column 1. So how do we delete it? This is a simple command where we can say delete df and column name. So delete del, df, and the column of interest. So in this case, col1. So when we execute this command, Python drops that column from the data frame. So we can see that column 1 doesn't exist in the data frame anymore. Also, there would be cases where you want to perform some sort of string operations on a column. So in this data frame, we have a scope to perform some string operations on the column salary and sales. Or in fact, we could actually augment or create a new column with a completely new business rule, which could be a string one. For simplicity, let's start with salary. Let's say we have all these values in lowercase. What if we wanted to cast them to an uppercase? Let's look into this. We could access the column and convert it to a string. So for example, we have df as a data frame. In data frame, we access a specific column of interest, and that in this case scenario would be salary. Now salary is actually an object. To invoke a string related function, we need to cast that into str, that is string. So the moment we say .str, we invoke the string related operations. And then we can call any string related function. So let's say we have plans to convert it to an uppercase. So if we just call the upper function, and if we execute this, we can see that all of them have been converted to uppercase. Similarly, the string library actually provides a rich collection of functions that could that could help us do any sort of string operation. So let's say something as common as string substrings, or searching a substring within the entire string, or concatenating two different strings, or converting to lowercase, or replacing a certain part of a string. All of these functions are easily available within the string library. I would recommend to all of you to explore what additional functions do we have in the string library for pandas. Before moving on, I would like to show you one more simple string manipulation. So let's say we want to create a new column called salary which is concatenating a new column. So we create df new salary is equal to salary. We convert it to an uppercase, and then we also concat that with new. This is just a demonstration to show how do we do string concatenation. This process might not make any business sense. Let's just have a look at how the outcome looks like. Now if you look at df, we can see that we have a new column called new salary, and that has the uppercase value for the salary concatenated with new. So how do we filter a data set? We've looked into basic data manipulation steps. Another data manipulation step would be to filter the data frame based on some condition. So let's say we have the data frame where we have several values for the column number of projects, right? Number of project. What if you have to filter values based on number of projects and you want a data frame where we have values only more than 5? So from the description which we saw when we did a data describe, so if you remember, we did describe on this data set, and as an outcome of that, we are confident that we have around 7 as the maximum for number of projects. Over here we can see that the number of projects has a maximum value of 7. So we want to filter the data frame. We can have only values more than 3. That is, we would like to have only values 4, 5, and 7 in the data frame. So what you can do is we can create a new data frame, and you can say that we filter the data frame with the respective column. So inside this, we write a filter condition. We'll say df of number project greater than 4. You can actually write several conditions with a logical operation. So let's say you want to use and or operations. You can just use the round braces to actually separate the different conditions. So this is filtering the data frame just on one condition. And we can see that df new is a new data frame with 12 columns and 419 rows. Just to be double sure that the execution is actually correct, let's check what is the value that we have in the new column. That is number project. Let's take a max and a min. In fact, let's take a min first. So if you take a min and if you find values like 0, 1 or 2, that would be your surprise. And you can see that the minimum value is 5. So values 0, 1, 2, 3 and 4 have been eliminated. So the filter works successfully. You can in fact add several more conditions to the filter condition. So let's say you can have one more condition. You can just separate the same condition with round braces. And you can add an add condition or an or condition based on your requirement. Let's say we want number of projects greater than 4 and salary is low. So we say df salary is equal to low. So these are two different conditions and using an AND operator to separate them. We can see df new, we have around 2000 rows with 12 columns. On exploring the same, we can see that number of projects and salary will have just the same value. Now to ensure whether salary has just the value low, if it has values like medium, then our filter has not worked properly. So how do we do that? We want to ensure that the values in the column salary are just low. What we can do is, in this scenario, we have a function that returns the number of unique values in each of the columns. For this specific column, let's extract the number of unique values present in them. So let's have df new. We choose the correct column. We have, let's say, salary. And we're looking at the number of this function unique provides us the number of unique values within that column. And we can see that it has just one value low. So the filter has worked properly. If we execute this command on the initial data set, that is data frame, here we're supposed to get more than one value. And we can see that yes, we have values like low, medium, and high. Let's look at how can we sort the values. So if we look into the data frame, now since we are using the visual tool and since we have a relatively low number of columns, it's easy to handle data by looking into them. If you want to sort the entire data frame based on one specific column, let's say you want to specifically sort the data frame on impact, so we can use the visual tool, but then this won't be handy all the time. So how do we sort the data frame based on a couple of columns using the code? So we have pandas function which gives us df.sortValues. In this function, you first pass the list of columns that you need to sort on. So let's say we need to sort on first impact and then the number of projects, number project. Now, how do we sort it? Ascending or descending? We provide another variable parameter. We provide a list of values that acts as a switch for whether it should be ascending or descending. The first one, this is 0. The second one, also 0. Let's say we make it 1. It just reverses the process. And you can see that the values have now been sorted. Similarly, you can add more number of columns and more number of switches over here. The default would be ascending, so you can just ignore this and you can execute this command. And let's say we store it in a new column, new variable called df underscore new1 is equal to the sorted data frame. You can have the new values sorted and stored over here. So this covers a basic set of data manipulation and data exploration techniques. What have we learned so far? We have learned to load the data frame, look into the length and breadth of the data frame, and understand basics about it using the describe and info function. We can then look into what columns we have, access each columns individually, create smaller data sets or smaller subsets with specific columns of interest and specific columns of specific rows of interest. We can also filter them based on a condition as per our requirement. We can augment existing columns into new values. We can perform substring operations on categorical columns. We can also transform or in fact perform mathematical operations on existing columns or create new columns using existing columns. That's a basic set of operations. Let's look at some advanced operations that we can actually perform on the data frame. Now, these advanced data operations could be something analogous to a SQL group by, that is, you're rolling up data. What if we want to find out the average satisfaction level for each group under salary? That is something which is analogous to a group by function in SQL. So how do we do that in pandas? Let's take a look at it. Pandas comes with a group by function. So let's say we have a new column or a new variable called df grouped. We can create this variable column, we can create this new data frame with an aggregated version of the data frame at the salary level. So the quest is to find out the average satisfaction level for the different levels of salary. So we would first need to group it at the salary level. So we say df dot group by, and in the group by we provide the columns that we need to group it at. So in this scenario it's just one column, so we say salary. Now this creates a grouped data frame. We just provide one more switch. You'll say as index is equal to false, so that this column is not treated as an index, rather it would actually come as a column in the new data frame. Now once we group the data frame, we can actually summarize the data. So how do we summarize? We select the column of interest, and in this scenario we say satisfaction level, and we execute a summary operation. So let's say we take just a random number, we take the sum of them, and we execute this command. We can see that The satisfaction level will be summed at this group. If we explore this variable, df group, we'll have three values: high, low, and median. And we'll see the respective sum of all the values under these three groups. Now, sum is not an appropriate one. We have to take mean. If we take mean, we can see the average values under each of these different groups. So we can see that the lowest number is for low and the highest number is for high, which makes sense. Normally, employees who are paid well are actually much satisfied than others. This could be taken to a further level if we want to actually group it at a multiple group level. So let's say if you want to execute the same exercise, but we want to group it along with salary also with sales. So for each department, we're trying to look into how does the satisfaction level look across different salary levels. It's the same thing, just with one extra level of grouping. And if you take into account, so we have for each value of salary, every department's satisfaction level. Now, since we have a lot of different values over here, it might be a little difficult to actually visualize and understand using this tool. The best way to consume this data is by plotting a graph. We'll get into data visualization in the next section, but then for now, we can understand that we can actually group at several levels, and in fact, we can also create additional new variables at a summary.